Hello dear students, today I'll discuss about 13.1 exercise, that is on the basis of limit. Just in the previous section we have seen that the algebra of limits, how can we find the limits, some rules for finding limits. Okay, here limit finding. So what is limit finding? Means suppose here x tending to a, here some function is here, that is maybe rational function, maybe denominator, maybe nothing is in denominator, but if rational function is there, some function upon some function, some polynomial upon polynomial, or trigonometric function upon trigonometric function. Okay, just we are trying to find the value of this function by putting x equals to a here. Suppose fx upon gx, like this. Just if x equals to, after putting x equals to 1, if we can get a definite value, then that is the limit for finding the limit. Okay, the process. And also whenever the denominator is 0 and also numerator is 0, then we are trying to removing common factors from numerator and denominator. And if denominator is finite and numerator is 0, then limit is 0. If denominator is infinity and denominator is finite, then limit does not exist, infinite limit. Okay, so just whenever we see that the 0 by 0 form, that is numerator 0, denominator 0, for this value x equal to a, after putting, then we will try to reduce this function in such a form that we can put x equals to a and find the value, some definite value, that will be the limit, if we can do that. So here, just if both are 0, then there will some common factor, so just remove the common factor and then try to find the value at x equal to a. If definite value we get, then that is the limit. Okay, so here, and also algebra of limit, you know, the addition, subtraction, division, we can just limit is distributed, numerator also denominator, and is multiplication, then you can distribute in multiply as a multiplication of function with separately with each function. Okay, and if addition and subtraction, then also can distribute it limit. Okay, so here solution of 13.1 question 1. So here some questions, very simple questions are given. Limit x tending to 3x plus 3. Limit x tending to 3x plus 3. So this is a function is what? X plus 3. Denominator having 1. So just we are trying to find the value of this limit. How? Just distribute it. Or here only 3. So we can put the value like this, x tending to 3, x plus limit x tending to 3, 3. So what? Here x equals to 3. This is the function. So you can put x equal to 3. So 3 plus here 3. Nothing involving x. So this is constant. So 3. This is equals to 6. 6 is the limit. Okay. Similarly, question second. Just you can see the question second. What is question second? X minus 22 by 7 x tending to pi. Limit x tending to pi x minus 22 by 7. So here just same process, we can put x equals to pi directly. Okay, so limit x tending to pi x minus limit x tending to pi 22 by 7. So what? Pi minus 22 by 7. So x equals to pi. This is definite value. So here constant. So constant. This is answer. Okay. Similarly, question third. Question third is a limit x tending to r tending to 1 to pi r square. Limit r tending to 1 pi r square. This is function. Just after putting r equals to 1, we can get value here. This is equals to pi 1 square. So pi into 1. That is pi. Pi is the limit. Okay. Means here main thing is what? The processor. How can we find limit? Processor is what? Just put the value r in this function. If we get definite value, that will be the limit. So here question 4. What is 4? Limit x tending to 4x plus 3 by x minus 2. So here we see that 4x plus 3 by x minus 2 x tending to 4. So its value also we can find, because x equals to 4 here, then 4 minus 2, 2, and 4 into 4, 16 plus 19 by 2 is answer. Okay. So because x equal to 4, we can put and can find definite value. So 4 into 4 plus 3 upon 4 minus 2. So this is equals to what? 16 plus 3 by 2 equals to 19 by 2. So just put the value. If you can get definite value, that is the limit. Now question 5. Question 5. Just see. I will discuss each questions, because very simple process for finding limit, just from easiest form to the toughest form we have to see. How can we find the limit? So here simple process. First of all, just see whether you can get definite value by putting the tending value in place of x. So here 5x to the 10, 5 and plus 1 by x minus 1. So question 5, limit x tending to x to the power 10 plus x to the power 5 plus 1. Okay. X to the power 5, 10, 5, 1, x minus 1, x tending to minus 1. X tending to minus 1 is there. Okay. X minus 1, x tending to minus 1. Your tending value is minus 1. X tending to minus 1. X tending to minus 1, and this is the function. It is rational function. Just we can see that we can put the value directly, because denominator will not be 0. X equal to minus 1 minus 2. So we can put direct value here. Just like x, in place of x, x minus 1 to the power 10 plus minus 1 to the power 5 plus 1. In place of x, just put x equal to minus 1. And here minus 1 minus 1. So we see that minus 1 to the power 10 means 1. Even power. Here minus 1 plus 1. So 1 upon minus 2, that is minus half. Minus half is the limit. This is definitely. Sixth question. Okay, question 6. X plus 1 to the power 5. Question 6. Limit x plus 1 to the power 5 minus 1 upon x tending to 0. This is the way. So here we see that when x equals to 0, we put in this place and in this place also. Separately you can do it also. So what? 0, 1, 2 by 5, 1, 1 minus 1, 0, 0 by 0, 0 by 0 for. After putting x equals to 0 in numerator and denominator, we get 0 by 0 form. 0 by 0 form. So just we will try some other way for finding limit. Okay, here this upon this. Here we can try, whenever this type of combination are given, then just try to find the limit by factorization. Here factorization is not so suitable. So here we can put x plus 1 equals to y in another variable, that just we can try. So let x plus 1 equals to y. Okay, then it implies, then we see that from here x tending to 0, as x tending to 0, then x plus 1 equals to y. Just suppose this is x plus 1, just suppose this is y, another variable. Then here as x tending to 0, if x tending to 0, then this will be 1, so y tending to 1. So as x tending to 0, y tending to 1. So we get limit, x tending to 0, 1 plus x power 5 minus 1 upon x is equals to limit y tending to 1. X tending to 0 means y tending to 1. Here y to the power 5. Y to the power 5 minus 1. Y to the power 5 minus 1 upon x. So here x equals to y minus 1. So we can write y minus 1. Okay. Now this is equals to what? We know formula, since limit x tending to a, x power n minus constant upon n a to the power n minus 1. We know this. This is our basic formula. So we can use here y to the power 5 minus 1 means we can write as 1 to the power 5. So this is equals to, we can write limit y tending to 1, y to the power 5 minus 1 to the power 5 upon y minus 1 equals to, y minus 1 equals to. So what? N a to the power n minus 1, 5 a to the power 5 minus 1. 5 a means 1 to the power 5 minus 1. So this is equals to 5 into 1 power 4 equals to 5. So 5 is limit. Clear? So what is used here? This formula. In place of y, x, here y. X tending to a equals to 1 here. A equals to 1 and y tending to 1. Y tending to 1, here A, 1, 1, 1. Y is variable, y and y to the power n means 5. So what 1 can be written like this. So limit is 5. Okay. So this type of techniques just you have to use for finding limit. So this is question 6. Now take question 7 here. Okay. Question 7. So here limit x tending to what? 2 and 3x square minus x minus 10. 3x square minus x minus 10 upon x minus 2. X square minus 4. Sorry, x square minus 4. So just here we see that after putting also x equals to 2 in numerator and denominator. So here 2 square 4 minus 4 0. So here 2 square 4 into 3 12 minus 2 10 minus 10 0 by 0. Here after putting x equals to 2 in numerator and denominator, we get 0 by 0. Clear? 0 by 0. So we will try to remove common factor from numerator and denominator, because numerator is polynomial function and also denominator is a polynomial. So they have some common factor as x minus 2, because 2 is what? Tending point. So because after putting 2, just we get the value of polynomial is 0. So x minus 2 will be factor in numerator and denominator. As x tending to 2 not equals to 2, so we can cancel out that. So we have limit x tending to 2, 3x square minus x minus 10 upon x square minus 4. This is limit x tending to 2. Just factorize it. Okay, factorize it. 3x square minus x minus 10. I think x minus 2 into 3x plus 5. Just its factor can be right. X minus 2 upon x minus 2 into x plus 2. Just you have to do its factorization in your rough work, then you can write like this. 3x square minus 6x and plus 5x, so minus x and minus 10, 3x plus 5. Okay, so this is its factorization. Now x minus 2 can be cancelled out as x not equals to 2. So this is equals to limit x tending to 2 x tending to 2 3x plus 5 upon x plus 2 as x is not equals to 2. That is what? that is x tending to 2. Okay, now we can put the value of x equals to 2 in this. So 3 into 2 plus 5 and we get 2 plus 2. So 6 plus 5 upon 4, that is 11 by 4. This is the limit, 11 by 4. Okay, so this is the procedure for finding limit. Now take question 8. One by one we can see the solution. Okay, x power 4 minus 81. So here x power 4 minus 81 upon 2x square minus 5x minus 2x square minus 5x minus 3, 2x square minus 5x minus 3. Here tending to 3 is there. Clear? So this same type of procedure also you adopt here. Okay. Here also we can see that if we put x equal to 3, here after putting x equals to 3, just you can write, because same type of procedure here, x equals to 3 in numerator and denominator, we get 0 by 0 form. Okay, 15, 18 minus 15 minus 3, 18, 0. Also here 3, 3, 9, 9 into 9, 81 minus 0, 0 by 0. So just same process, we have to factorize and try to remove common factors. So here we see that x square, x square 9 square. So x square minus 9, x square plus 9. So x square minus 9 means x minus 3, x plus 3. And here x square plus 9. Just this type of factorization, very simple factorization is there. Now here also we see that x minus 3 into, just you do its factorization. So x minus 3 into, just you can do the middle term in rough work, just you could do 2x plus 1. So 2x plus 1. This is the factorization of denominator, just factorize it. Now here these two can be cancelled out. So we get limit x tending to 3, x plus 3, x square plus 9, 2x plus 1. Okay. Now just we can put x equal to 3 and get finite value. So 3 plus 3, 3 square plus 9 upon 2 into 3 plus 1. Okay. So what? 6 into 18. 6 into 18. 6 into 18 upon 7. So 108 by 7. This is final. So this is the limit. Now question 9. Just you can see ax plus b by cx plus 1 and x tending to 0. Question 9. Question 9 is very simple, just like this. Question 9 means what? Limit x tending to 0. Question 9 what? X tending to 0, ax plus b by cx plus 1. Ax plus b by cx plus 1. So its limit is very simple. Just we can see. If we put x equal to 0, then a into 0, 0, c into 0, 0, and b by 1 is b. Limit is b. So this is very simple. Take question 10. Just question 9. X tending to 0, this we can put a into 0 plus b upon c into 0 plus 1 equals to b by 1. This is b. B is limit. Okay, limit is b. Now question 10 here. Limit. Here limit what? Z tending to 1. Z 1 by 3, 1 by 6 minus 1. Z tending to 1. Z power 1 by 3 minus 1 upon Z power 1 by 6 minus 1. This is the limit. Just we have to find its value here. We know the formula as what? X to the power n minus 1 upon a. Just we know its formula. Since limit x tending to a, x to the power n minus a to the power n upon x minus a equals to n a to the power n minus 1. This formula we will use here. Okay, here at we see that at z equals to 1, that is tending point 1. If z equals to 1, then 1 minus 1, 0, 1 minus 1, 0, 0 by 0. The rational function. The rational function. Because it is rational function. Some polynomial upon some polynomial. So here we see that at z equals to 1, the rational function this takes the form 0 by 0. So let here we can, because factorization is impossible here, so we can try to convert it in like this form. So we can use let z equals to 1 by 6 equals to 1. Let variable to the power 1 by 6 equals to 1. Then as z tending to 1, y tending to 1. If z tending to 1, so 1 to the power 1 by 6, 1. So y tending to 1. Okay, so we can use this formula for new variable. Therefore, limit z tending to 1, this limit 1 by 3 minus 1 upon z power 1 by 6 minus 1 equals to, can be written z tending to 1 means y tending to also 1, and z y minus 1. Here, if we put just z square means what? Just 1 by 3. So we can write it can be written as, first of all, just write it like this: limit z tending to 1, z power 1 by 3 power 1 to 6 minus 1, z power 1 by 6 minus 1. Now z tending to 1 means y tending to 1. Just convert y tending to 1. And here this is equals to y, that is this is equals to y minus 1. And numerator, this is y square. Z to the power by 6 into y, this is y square. So y square minus 1. Clear? This 1 can be written square also, this 1 can be written y square. Now use this formula. Here 1, 1, 1, a, here y, n equals to 2, n equals to 2. So this is equals to 2a power 2 minus 1 equals to 2 into 1 equals to 2. Clear? So 2 into 1, limit is 2. Okay, so just convert in this form. Now take question 11. Question 11. Limit x tending to 1, question 11, a x square plus bx plus c upon c x square plus bx plus a, c x square plus bx plus a plus b plus c equal to not 0. It is given that a plus b plus c equals to not 0. This limit we have to find like this. Constant, ABC are the constant. Okay. So here x tending to 1, limit x tending to 1. So what will be the value of this limit? So very simple, 1. Okay. And how? Just we can use this because ABC are constant, so we can put x equal to 1 in numerator and denominator. So after putting, just see what is the value. Okay, so this is equals to a into 1 square at x equals to 1 plus b into 1 plus c upon c into 1 square plus b into 1 plus a. So here a plus b plus c upon c plus b plus a, both are same. So equals to 1. Just put it. Only substitution. So yes, a plus b plus c equals to not 0. So we can cancel out. So limit is 1. So limit is 1. Clear? Now here see question 12. Limit x tending to x tending to 2 extending to minus 2 is there, extending to minus 2. Okay, x tending to minus 2. X tending to minus 2. Just keep it here. Question 12. One by x plus 1 by 2 upon x plus 2. So this is given rational function and we have to find the limit. So x tending to minus 2. If we put we see that at x equals to minus 2, the value of rational function takes form 0 by 0. X equal to minus 2, minus 2, minus 2, minus 2, minus plus 2, 0, minus 2, minus plus 0. So, in this case, just here we see, let's try to take LCM, then x plus 2 will be cancelled out from numerator and denominator. So, we have what? Limit x tending to minus 2, 1 by x plus 1 by 2, x plus 2 is equals to limit x tending to minus 2, just 2x and 2 plus x. Okay, 2 plus x upon x plus 2. We see that this cancel out and we get x tending to minus 2, 1 by 2x. So this is limit x tending to minus 2, 1 upon 2 into minus 2. So this is equals to minus 1 by 4 is the limit. Okay, just direct putting we get 0 by 0, but after taking LCM and just cancel out common factor as x equal to not minus 2 from numerator and denominator, we can get this type of value. So this is final value, this is the limit. Okay, so 12 having limit what? Minus 1 by 4. Sin ax by bx extending to 0. Question 13. Limit x tending to 0 sin x by bx. We know limit what? Limit x tending to 0 sin x 0. Limit x tending to 0 cos x 1. Limit x tending to 0 sin x by x 1. We know just we will use this for trigonometric limit. Okay, so this here for this limit, just see x tending to 0, x tending to 0. So there may be some combination x plus 2, x plus 2, x plus 2 tending to 0, 2x tending to 0, bx tending to 0. Then you can write 1. So here you can combine like this: sin ax upon ax into ax. Just we multiply numerator and denominator by x upon bx. This is multiplication. Now limit x tending to a sine here 0, sorry 0 tending to 0, in this question tending to 0. Okay, so sine ax by x into limit x tending to 0 ax by bx. This limit can be separately written with multiplication. Okay, so distributed as a multiplication, so we can write like this. Now limit ax tending to 0 sine ax upon ax, limit x is not 0, so we can write a by b, x cancel. Clear? So here x as x tending to 0, x tending to also 0. As x tending to 0, x tending to also 0. X tending to 0, so a constant into multiplication tending to also 0. So this is tending to 0. So x. So you can write 1 here. So 1 into here constant, so a by b. So limit is a by b. This is limit. Okay, just we are trying to adjust in the form of main formula as a standard formula. Okay. Similarly, sin x by sin bx is question 40. Constant a and b are not equals to 0. So just we have to find the limit, this limit. And we know the limit is distributed in numerator and denominator also. So here we can set like this: limit x tending to 0 sine ax by ax into ax. Okay, sine bx by bx. Just we can write like this: in the numerator x, ax into x. Just we multiply numerator by x, bx and divide ax, bx. Here numerator sin x, denominator sin bx. Okay, now distribute this 3 limit: x tending to 0 sin ax upon ax. First limit, limit x tending to 0 ax upon bx, limit x tending to 0 bx upon sin bx. Just distribute 3 limits. Now here same logic, since x tending to 0 implies x tending to 0 bx tending to 0 is x tending to 0, then a into constant is into x tending to 0, b into x tending to 0 also. So here we can write x tending to 0 sin ax by x into limit x tending to 0 a by b. As x not equal to 0, cancel out. here limit bx tending to 0 sin 1 upon sin bx upon bx. We can write like this. Okay. Now, this is equals to 1 into this is a by b into this is 1 upon limit of 1 is 1 upon limit bx tending to 0 sin bx upon bx, because limit is distributed in numerator denominator also. Numerator limit 1 constant, so denominator limit this. This is equals to 1 into a by b into 1 upon 1. This is also 1. So a by b is limit. Okay, just we can adjust in the form of main formula by using this x tending to 0, bx tending to 0. Then by using this formula we can get 1, here 1, so a by b is the limit of 13 also. Okay, now question 14. Now this is 14, so 15 question. Question 15. Here, limit x tending to pi, sin pi minus x by pi minus x into pi. Sin pi minus x upon pi minus x. Sin pi minus x by pi minus x. Clear? Now, here, how can we find its limit? Just sin pi minus x upon sin x tending to pi, denominator is 0. Numerator is 0 after putting 0 by 0 form. Okay? So here zero by zero form. So just try to write this constant 1 by pi. Limit of constant is same thing. So constant can be taken outside. 1 by pi. Now limit sin pi minus x upon pi minus x. Here x tending to pi. Since x tending to pi implies pi minus x tending to 0. Just pi minus x means x minus x 0. Pi minus x tending to 0. So pi minus x tending to 0. 1 by pi limit pi minus x tending to 0. Just we can write pi minus x tending to 0. Sin pi minus x upon pi minus x. So what is this? This tending to 0, this tending to 0, this tending to 0. This tending to 0, this tending to 0, this tending to 0 means 1. Also we can write let pi minus x equals to y, implies y tending to 0. So you can write y tending to 0 limit sin y upon y. 1 by pi into 1. 1 upon pi. This is the limit. 1 by pi is the limit. So just we use what procedure? The standard limit, and just adjust in the form of the standard formula. Now take question 16. Cos x by pi minus x tending to 0. 16. Limit x tending to 0 cos x by pi minus x. Cos x by pi, x tending to 0 cos x by pi minus x. Its limit is very simple because you can put directly, because this, just you can write like this: limit x tending to 0 cos x upon limit x tending to 0 pi minus x, because you can distribute limit in numerator and denominator. So this, so limit x tending to 0 cos x, the cos 0 1, so 1, so this 1 upon pi minus 0, so 1 by pi, 1 upon pi is the limit. Okay, so this type of method you can use to find the limit. This formula is very, very important. Also we can see that limit x tending to 0 tan x by x equals to also 1. Okay, tan x by x equals to. How can we find it? Just like this: limit x tending to 0, tan x can be written as sin by cos, so just write sin x by cos x into 1 by x. Now we can write sin x by x in 1 plus, and also limit x tending to 0 1 by cos x. So its limit is 1, so 1 into limit. Just here limit can be distributed numerator denominator, so we limit 1, so limit x tending to 0 1 upon limit x tending to 0 cos x. So what? 1 into 1 upon 1 equals to also 1. So this limit is also 1. So it is also another formula: limit x tending to 0 tan x by x equals to 1. So these are the formula, very, very important formula. Trigonometric limit can be found by setting up in this form. Okay, so do also all the examples up to 16 we have done. From 17 just we will discuss about remaining questions in next class, and you have to do all the examples also. Okay, and up to this question in your copy, and send me some solutions for your attendance. Okay.